cowboy armed with a ray gun against hordes of enemies from all directions. My player must face infinite amounts of bad guys to get on the leaderboard. There are special orbs that are moving and stationary, but when shot the stationary orbs teleport to a new location, and moving orbs are reset off screen. The object of the game is simple: try and score as high as you can to get top position on the leaderboard. You can play in 3 settings, which are easy, normal or hard. Here's our game. So it has 3 settings: easy, normal and hard. We're just going to pick easy for this demo. Click OK. We're going to enter in our name. So if we keep on entering past 6 characters, it cuts it off, and backspace allows us to delete. So just to keep things simple, we're just going to go 1, and then we'll hit number 9 to enter. We're going left, right, up, down, diagonally. That works in W, S, A, D, and also the cursor keys. We can also hold down the B at the same time, and that will give us a boost, so we can go faster, and that works in all directions. We can also go diagonally as well. We can do shooting, so we don't get killed. We can go shooting. And as you can see, we have sound along with custom graphics for both the bad guys and the orbs, which gives us, if that was 5 points, and the yellow orb is 10 points. Let's see if we can get a yellow orb just to show you that we have 10 points. So, oh, missed. So we have a score of 12, which is 1. So what we're going to do is I'm going to load up the scoreboard, and then we will get back into it. Here we can see we've overloaded the scoreboard. So we have positions 1 to 5. So we have 19, 18, 17, 14 and 12 in the score. So we're going to hit Y again, and it's going to start another game, and we're going to knock name 1 off. So we're just going to see if we can score 20. So we put it in a new high score. So we will just call this Robert, and we'll go for a high score. Right, here's our high score here. So if I then get killed, last life, you're dead, and you see my new score is 34, and number 1 is gone. And we'll just hit Y again to play the game, and we'll just put in Paul, different name. We're going to hit 9. So if I hit a normal bad guy, it's 1 point. If I hit a stationary one, it's 5. There's 6. Now if you get an orb, that should be 10. They're a little bit hard to get. There's 16. So there is our score of 1, 5 and 16. And then if we just get killed here and get killed again, we'll see that we're Paul is score 20, which is the 2nd position. So that was my game. I hope you enjoyed it. And if we hit N, that will exit the game. The hardest level, just to kind of show you the difference in the enemies. We're going to put in just the name, and this is just to kind of show you what happens when you go for the harder level. There's more bad guys. They respawn in bigger numbers. You also have 1 stationary and 1 orb, so the chance of getting the bonuses are also harder as well. Construction. So if we go to user input, we see that it's just got 1 constructor, no overload constructor. Default is 15, 18 is the overloaded. Good guy we have 14, and then overloaded 17. And the bad guy would have default on 12 and overloaded on 16. If we look, line 54 takes in 0 parameters, returns a string value. It is used for mapping out all the directions, so I can have vertical movement as seen in line 59, where I check if left and down are true and right and up are false. To create down and left direction player can move in. The true false values come from methods good guy move pressed on line 67 and good guy move released on line 76. This is how I can have 2 buttons true at the same time. Good guy move pressed on line 67 and good guy move released on 76. I check for key cursor and specific keys set direction. For example, line 68 checks for left key code and lowercase and uppercase A, so the left can be true, resulting in use of set direction back in line 54, method direction moved. Line 68 to 71 and line 77 to 80 allow me to have 2 keys for direction active at the same time, and these 2 methods are called in the main tab. On line 400 and 410 in the key pressed and key release function, on line 398 and 408. If we go up to line number 63, 64, 65 and 66, is where I declared object arrays of projects, bad guys, moving orbs, and stationary orbs, which is the second type of bonus orb. Object arrays are initialized on line 111 for projectiles, 117 for bad guys, 124 for moving orbs, and 131 for stationary orbs. Line 112 to 114 is where I loop through the projectiles and place them off screen and call them in as needed. Line 204, we loop the projectiles array, where on line 205 update the projectile. 210, I use projectile and collision detection methods passing value to find hit the bad guy, same as for the two bonus orbs on lines 215 and 220. 211 to 221 resets projectiles if collisions are detected. Line 232, 251, another projectile reset is called if the good guy dies or clear projectiles. Line 248, I display the projectiles object. Line 118 to 121 is where I loop through the bad guys and reset them to start off screen at random locations. 206, we loop the bad guys array on line 210, we do collision detection against projectile. Line 212, bad guys respawn off screen to chase player again if hit. Line 227, bad guys use the collision detection method, this time against good guy. Line 228, bad guy is used another loop where on line 233 the bad guys respond if the good guy has been hit. Line 261, the bad guy is updated. Line 262, bad guy is displayed in the game. Line 125 to 127 is where I loop through the moving bonus orbs and reset them to start off screen at random locations. Line 207, we loop the bonus orbs array. On line 215, we do collision detection method against projectile. 217, we respawn moving orbs off screen if hit. Line 227, bonus orbs is used collision detection method is passed in value for collision with good guy. 229, bonus orbs array is used another loop where on line 234 the bonus orb is respawned if good guy has been hit. For collision detection, line number 332, good guy hit returns a Boolean value, either true or false, which takes in objects check, and we compare the objects x, y, height, and width, which are all getters. We then can calculate this between x and y as we use x and y coordinates to get the absolute value magnitude of a number and return true if both object coordinates are close enough, including the width and height, or in this case diameters. Both objects are essentially circles. Bonus orbs tab, line 85. I have a method called check bounds, which checks the moving orb's position against the left and right edges on line 86 and 89. This is from hit detection. And if the orb is at the edge minus half the diameter, this just keeps the orb on the screen. I set the speed x or y on line 88 and line 91 by multiplying it by -1, which effectively makes the orb travel in the opposite direction, which gives the appearance of orbs bouncing off the game's walls. Line 99 and 100 do the same thing, but check for top and bottom in the game area. I move my orb by changing orb x and y on line 44 and line 45, as I am adding the speed value to the position x and y coordinates for movement, which is why I was changing the speed x and y previously for traveling direction. My high score, I go with the main tab and I go to line 357. This is where I check to see if the score is higher than what is set at index 0, as my loop is sorted from lowest to highest. The 0 index will always have the lowest number stored in line 367. I loop the scores array and if statement on line 368 to compare the first array value to the next array value, and loop through array looking for higher values to move to the end of the array index. Line 369, I create a temporary variable to store the current index value if the current value is higher than index +1, which is the next value. Line 370 and 371 is where the next array index value is moved to the current array index position, and is where we assign the value that was saved in the temporary variable to the next array index value, which is I +1. Line 372 to line 374 does the same operation on names array, as the array length is the same for scores and names. And doing this, we keep the information in both arrays at the same array index value, as key to keep information together later on a high scored board. Line 375, we set the duration variable I back to the current position, which is I -1, as we assigned it one position ahead on line 371, and this leaves the variable I back to the correct position for the main loop to run again to sort out the values from lowest to highest.